The ratio test is another useful test for deciding whether or not a series is going to converge or diverge. And instead of comparing the series with a different series, in a sense, you compare the series with itself. In particular, you compare the terms an with the next term in the series, an plus 1. So here's what it says precisely. If you take the limit as n goes to infinity of the ratio of an plus 1 over an, absolute value of that, and you get some quantity L, which could either be a number or infinity. It just can't be dne. Then we're going to make some conclusions about the series depending on the value of L. If the value of L is less than 1, then we will know that the series converges absolutely. And if the value of L is greater than 1, that implies that this series diverges. You can arrive at these conclusions by thinking about the geometric series and how it would play out in that situation. However, there is actually a third possibility. You might end up finding that this limit is equal to 1 instead of less than or greater than. And if that happens, the test doesn't actually tell you anything. You're going to have to go and use a different test. So I'll illustrate the ratio test with this particular example, which has a factorial in it. In general, if you see a factorial in your series, the ratio test is a good option. Doesn't work every single time, but it's a good option. So we've got the sum from n equals 1 to infinity of -3 to the power n divided by 2n factorial. We will apply the ratio test. And so once I actually replace an plus 1 and an with their expressions, we get the following. So let me just break down how I got this result. The first part of this quantity that's inside the absolute value is the an plus 1. And I got that just by taking the original terms of the series, the formula for them, and replacing the n with n plus 1. This n also got replaced with n plus 1 in parentheses. Then you could divide by an. That would lead to a fraction of fractions, which can look intimidating. So instead, I multiply by the reciprocal of an. So I took the original formula for an, flipped it, and multiplied by it. Now we're going to have to see how this quantity simplifies so that we can evaluate this limit. It's going to be useful to group together the things that have like the -3's together and the things that have the factorials together. And when I group together the things that have the factorials, I'm also going to multiply this 2 into the n plus 1. So now I have in the denominator 2n plus 2 quantity factorial. We'll start by simplifying the first part of this quantity that's inside the absolute values. So I have something like x to the n plus 1 divided by x to the n. That's a situation where you subtract the powers, and n plus 1 minus n is just 1. So all that remains is -3 to the power 1, but we don't bother writing that. And now I'm going to want to simplify the second part of the quantity inside the absolute values. And to do that, it's going to be useful to rewrite the denominator in a more direct way. So remember, like n factorial means you would take n, multiply it by n minus 1, multiply it by n minus 2. You just keep multiplying, going down one integer in each factor. So when I have 2n plus 2 factorial, it would start with 2n plus 2. Then I'd multiply by that decrease by 1, which is 2n plus 1. Then I would get to 2n, and it would continue decreasing, which is the same as just 2n factorial. So this factorial here is only affecting the 2n. The benefit of writing it this way, I hope you can see, is that we have a 2n factorial over a 2n factorial. Those are going to cancel, and that gives us a simpler expression. -3, I'm just going to bring it into the numerator. And in the denominator, I have a product of things that have n involved. In particular, I'd end up with a polynomial of degree 2 in the variable n. So when I take this limit as n goes to infinity, this limit is going to go to 0. 0 is indeed less than 1. So if we went back to our cases, that's the case where the series converges. In fact, it converges absolutely. So if you see a factorial in your series, definitely consider using the ratio test. It can be used in other situations as well.